Hi students, we're going to talk about lesson 3.9 today, proving lines parallel. So following up from what we did before, this is always fun when it does this, there we go. Following up from what we did before with taking the fact of having parallel lines and proving things we know, we're reversing that idea today. So you're going to see a lot of converses today. To theorems, you're going to see that word come out a bunch, but we talk about the converse of the relationship, which is if we switch the if and the then part of the statement or the hypothesis of the conclusion, and what we get from that. A reminder on this, I do not allow you to use the names of these theorems. You're going to see the textbook use that, but please do not use these names, and I could go through and do this. I need to see the if-then statement, and I'll try to give you the easy version of that. So this one says if two lines are cut by a transversal. So again, imagine two lines cut by a transversal. We have there's our transversal. I'll say that, and I'll say this is line A and line B, so that corresponding angles are congruent. So it's telling us that we know that we pick a corresponding angle that are congruent. What we then know, so this is the if, so if we know this, then we know that those two lines A and B are parallel to each other. Okay, so we've reversed the if and the then. We don't know that they're parallel. We know that they're congruent instead, and we're proving that they're parallel. So my if-then statement here is going to be if corresponding angles are congruent, then we have parallel lines, and that's how you're going to be able to write that. Again, I expect to see the if-then, not the corresponding angles theorem there. Okay, if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. That's just a parallel postulate. That's more kind of just working through some stuff. Again, the idea of this, given a line and a point not on the line, that's what you're given, then there exists exactly one, I'm going to change colors for that. So then there exists exactly one line through the point that is parallel to this one. So there's one line you can draw that is parallel to that first one that's there. Okay. Again, you're not going to use that with proofs. So parallel lines are cut by transversals. We showed that, and we're going to have a few different things. It's not just corresponding angles. Don't know what just happened there. Where did we end up at? Oh yeah, here we go. It's not just corresponding angles. We also have something that is true about a bunch of different pairs of angles. I'm crossing these off because, again, you are not going to use those names. So we've got to look at what else we know. So if two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent. So if we have alternate exterior angles that are congruent, then we know that we have parallel lines. So there's your if then for that one. Here it's talking about consecutive interior angles. Just a reminder, this is the same as same side interior angles. So if same side interior angles, this one is the one that's not congruent, are supplementary, then we can state that we have parallel lines. This one down here, alternate interior angles congruent. So if alternate interior angles are congruent, then we have parallel lines. And then the last one is the one where I'm not going to rewrite it because you pretty much have to write this, but if two lines in a plane are perpendicular to the same line. So if you imagine you have two lines and they're both perpendicular to this same line that's here, then those two lines have to be parallel there, just based on what it is. You can look at all different types of angles in that case, but that's just based on how those lines will work. Okay, so again, you have that statement there. If I'm putting everything in red that you need to know, that you also need to know along with everything else. So those are the ways to prove that you have parallel lines, and that's what we're looking at here. So this says use the given information to determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So in this picture, it seems that L and M are parallel and N and K are parallel. We don't know if that's actually the case. So just imagine that L and M are both at, let's see, what degree would this be? Like 40 degrees, and this one's at 39 degrees. To the naked eye, you can't tell. And so what we're looking at here is there information that's given to us that shows us that these are, in fact, parallel. So we need information given to us. So if I look at this, angle 1 congruent to angle 15. So if I know angle 1 is congruent to angle 15, does that prove that these lines are parallel? And so I can go through this and try to figure out, but what I'm really going to be looking at here is from angle 1 to angle 15, where is the transversal? Okay, so where is the transversal? And what that's going to do is it's going to kind of tell me what these lines are. The transversal helps me with what are they alternate, are they same side, and whatnot. Now, a transversal should touch both of the angles. So angle 1 is made out of L and it's made out of N, and angle 15 is made out of K and it's made out of M. So there is no transversal here. So alternate exterior does not happen. Alternate exterior does not happen. Corresponding angles does not happen, which means this one is letter D. It's not possible to determine whether those lines are parallel based on that information. They could be, but they could also not be. Okay, so that will happen once in a while. You got to be careful. But you are going to, number one, look for the transversal. So in letter B, measure of angle 3 plus measure of angle 10 equals 180. So I know that if I take this angle plus this angle, it's equal to 180. Does that give me enough information to justify that these lines are parallel? And if so, which ones? So the answer for this one is going to be a yes. If we look at these, those two, to answer this first question that's here, question number 1, those two angles both touch line L, so the transversal would be line L here, okay? Which means the two lines that intersect line L are line K and line N. So the lines that are going to be parallel are K is parallel to N. And the reason here is going to be that if, and I have to look at the pair of angles, 3 and 10 are same side of the transversal and they're both interior angles. So if same side interior angles are supplementary, and I do need to think about that, like if that's not what I need to know, then that doesn't work. So if it was same side interior angles are congruent and that doesn't prove what I need here, then that's not going to be enough. But this is what I need. If same side interior angles are supplementary, then we have parallel lines, and there's my reason there. Okay, again, we're not going to use the names. You're going to see it used within this, but we're not going to write those names. So then they talk about angle 3 congruent to angle 5. So if I knew that angle 3 was congruent to angle 5 in those two places there, what do I know? Well, again, first thing I'm going to do, like I wrote up here, identify the transversal. So line N is the one that touches both of those. Probably need at this point just to erase some of this. So line N is the one that touches both 3 and 5 in this one. And that makes line L and M the ones that are possibly going to be parallel to each other. So it's not N and K. And if I'm looking at the reason, these two are alternate interior angles. And so we would look at the alternate interior angles converse because it's written that way. That's what it is. But that reasoning is if alternate interior angles are congruent, then we have parallel lines. Okay, so that's what you see there. So there's your first 3 right there. Good ones to go over. Find the value of x so that m is parallel to n. So it's just a different way to word this. Instead of saying if m is parallel to n, find the value of x, they've just reversed that kind of concept. So they're saying find the value of x so that that's the case. Really read it as the same thing. Assume to yourself that m is parallel to n and do what you can with these two angles. So if I look at these two angles are both corresponding angles. And so I know that corresponding angles, 6x minus 3, are equal to each other. So I'm going to say equal to 2x plus 1. So here, my reason is going to be that if the value of x so that m is parallel to n. So if the angles are congruent, so I'm going to say if corresponding angles are congruent, and the reason I'm doing that is because it's saying find the value of x so that this is the case. So that's the conclusion right there, is that m is parallel to n. So if corresponding angles are congruent, then we have parallel lines here. And so I'm going to solve this so that's the case. So subtract 2x, I get 4x. Add 3 to the other side, I get 4. Divide by 4, I get x equal to 1. So my answer is x equals 1 for that reason there. In letter B, find measure of angle LMN. LMN, I got to associate myself here, okay, so that A is parallel to B. So again, we're going to kind of make the assumption that A is parallel to B in order to solve this. If I look at this, we can do it in a few different ways. So I do know based on the degrees that are given that these two are supplementary to each other. So I could do 2x plus 152.4 plus 4x plus 6 is equal to 180 and use that linear pair that's there. That's kind of ugly, so I'm kind of like, I don't want to do that if I don't have to. So what else I'm looking at is that since I want to do it as A is parallel to B, I should be able to solve with my angle that was given and with this angle up here, this RST. Those two angles are alternate exterior angles. And so they should be equal to each other. So I should be able to set 9x minus 12 equal to 4x plus 6. and solve that. And that looks a little bit nicer. So subtract the 4x, I get 5x. Add the 12 to the other side, I get 18. Divide by 5 on both sides, I'm going to get x is equal to 18 fifths. Let's see if I want to convert that or not. So that would be 3 3/5 or 3.6. I think I've got that right. So we would get that x value, and we want to find the measure of angle LMN. So I'm going to do 4 times that 3.6 plus, just making sure I'm doing this right, plus the 6. So I'm going to get, let's see if I can do some mental math here. I'm going to get 12 plus 2.4, so 14.4 plus 6. I'm going to get 20.4 for an answer there for those degrees. Okay, so that's what we have there. Here, applying this, and this is kind of a funky diagram to look at. It's a little bit hard to see, but is it possible to prove that support poles of the antenna complex are parallel? Justify your answer. So here we're given an angle is 120 degrees and another one is 54 degrees here. And we want to know if these poles are parallel. So if I continue these lines on to kind of see all of this, there's my transversal that's going through. So this is my transversal, and these are my two lines, A and B, that I'm going to label there. So the angles that are given to me, the 120 that's here and the 54 that is right there, should be same side interior angles, which should be supplementary. If I add 120 and 54 together, I get 174, which is not 180, so they're not supplementary. And so therefore, we can actually say that these are not parallel to each other. So we say it's not a yes, but we say that they are not because we looked at consecutive interior angles are not supplementary. So there's my reason right there. Okay, so that's where we're going to stop for today.